Okay, let's get this rolling. So the serverless revolution is the name of my talk. I've given versions of this talk, but I definitely rework it every time because the more often I give this talk, the more people know about serverless, and the more people know about serverless. You know what I mean? Like the higher number of people know about serverless, and the more they know about it. So I talk a little bit deeper and a little bit less introductory each time. But I will go into the introductory terms in this one still, because there are still a few people out there who are like, I've never tried it. I know it's called serverless, and I have a really funny joke about the name. So. Obligatory introduction, mix Kass Perch. I use they, them, their as my pronouns. As James said, I'm an electrical engineering student at Arizona State University Online. It was just a coincidence that it happened to be the university my father went to when I was a child. I actually grew up, one of my first memories was watching him graduate. It was the only ABET certified electrical engineering program that was all online. And because I travel a lot for work, I can't do in-person classes, so I was like, well, that's a coincidence. So I ended up at the same university. I am currently looking for DevRel work, but hopefully I'll land something before the holidays, because we all know that's not difficult. I'm also a NodeConf.eu alumni. I actually really love this picture. And Gordon, if you're in here, this is the picture I was telling you about. So that is me in the back, all of the rainbow streamer colors. That's a light up skirt I had that was based on one of the very first Esperino boards, which is the board that powers all of your badges. And I'm running, and someone had a very high exposure camera, and people in front of me were waving glow sticks to spell node. And it's still one of my favorite pictures of any of my robots, even though you can't tell it's me and you can't tell it's one of my robots. It's still one of my favorite pictures. Speaking of robots, I am a robots and NodeBots author. I have authored 2 books and a chapter. I'm never writing a book again, but that's what I said last time. I'm also I'm also overpowering my computer, and it's slowing down. So cat parent. I am also a parent to 2 lovely cats. The one on the left is Arya, and the one on the right is Ace. They're my babies, and I love them, and if you ask, I will show you 50,000 pictures of them. Right, serverless. Right, we're not here to talk about cats, for once. So the funny joke I have is the first time I ever went to a conference working for a serverless company, someone came walking up to me at the bar afterward, and I think they'd had a few, because they yelled at me, "We just spent 10 years convincing people that JS belongs on servers, and now they want to take servers away." That's actually what prompted me to make this talk, because I'm like, wait a second, that's not what we're not doing that. Serverless doesn't mean the end of servers, just like cloud computing didn't mean the end of DevOps. And before you get on this, serverless does not mean the end of ops either. Chill out, we're still gonna have ops. We will always have ops. It's also called functions as a service. I like that name a little better. It's a lot less of a misnomer than serverless, because there are definitely still servers. It's still not a great name, because I feel like it kind of doesn't fit with like infrastructure as a service and containers as a service. It feels like they're giving you the function, but you're giving them the function. So what should we call it? I don't know. I don't have an answer for that. So I'm just going to call it functions as a service and serverless until someone smarter than me thinks up a better name for it, or forever, whichever. But what is serverless, or functions as a service, or whatever we want to call it? The optimistic approach is that it's the latest abstraction. It's another layer we've added in order to allow developers to deploy code with even less need to control infrastructure. Yay! Write code, push button, works. Right? Great. That's the optimistic view of serverless. There's also a pessimistic view of serverless, the latest abstraction. So wait, now not only do we lose control over how our code is run, but now we rely on our third party to determine our language runtime, our environment, all of it. But it's easier for devs, so yay? That's the pessimistic version. The real one, it is the latest abstraction. We gain usability for developers, we create some visibility issues, there's some trade-offs just like there are with every new technology, and overall it's the way we've been moving since ever, because at the end of the day, developers love abstractions. Don't at me on this one, all right? I have pages of receipts. Developers love abstractions. So what is the abstraction, right? So with EC2 and similar services, cloud computing services, we abstracted out servers, right? We made a server less of a physical concept and more of a, I created a server, and I don't care if it's an actual physical server. It could just be one of many servers running on an actual physical server. I don't care. With Docker, we abstracted out entire environments. We created containers so that you can run environments wherever you want, however you want. Yay. So with serverless, we're abstracting out the runtime environment. And that might leave you thinking, how does that work? Like, what do you mean abstract out the runtime environment? So with EC2 and cloud computing services, you don't have to manage a physical server. With Docker, you don't have to manage your environment because you automated it out. With serverless, you don't even have to manage automating your runtime environment because someone else has done that for you. You write code for that runtime environment, you hit deploy, and as long as you wrote perfect code, because you totally do that all the time, right? Because I know I do, it works. Some people are like, why? Why are we going this far? Why are we abstracting out this much? Why are we giving up this much control over our infrastructure? Why is it a good thing? Well, for one thing, money is a good thing. And one of the main benefits is you only are billed by providers for the time that your function is actually running. So if you have a function that runs for 1/10 of a second and then shuts off, you're only paying for 1/10 of a second. Unlike with cloud computing services, if you have a cloud computing server running 24/7, you're paying for the entire time that the cloud computing instance. Sorry, I worked for an AWS-related company for a while. Can you tell? You were paying for the entire time the server was up. But with this, you're only paying for the time the function runs. And you do write, deploy, and run code, but like for realsies. I know, we say this all the time. We say it with every new thing. Oh, it's so easy, you just write the code and then you hit deploy and it runs. But like for realsies this time, you really actually do that. As long as you write for the runtime that your provider is giving you, it works. I mean, yes, that's kind of a big asterisk, but isn't there always an asterisk? It scales pretty darn well in spiky traffic situations. So it scales horizontally fairly well. Obviously, that depends on your provider. If you write your own and it doesn't scale horizontally and you at me about it, I'm not going to respond. But it's about the provider. But most providers, including the major ones, AWS Lambda, Microsoft Azure, IBM's OpenWhisk, they scale pretty well horizontally in spiky situations. And overall, this is a good thing because if you don't need that much control over your runtime environment, we have way more important problems to be solving, like how to fit a cat and a keyboard on the same desk. Now, I thought I'd solved this problem, but just like every problem, it had a new iteration. So as you notice, you can kind of see in the background is my Ergodox. He shoved it out of the way and sat on my arm. And I had to he's a 15-pound cat, so my arm went numb after like 2 minutes. And this was like during a meeting, so I'm like trying to talk to somebody and look professional with this giant cat on my arm. Anyway, new problems. So now demo time. If you go to that URL and you replace the brackets with a named CSS color, or if you can type a HSL or whatever color into the URL, the badge in front of me should change color. It's kind of drowned out under these lights, so you can kind of see it changing. I'll let y'all do that while I walk through the actual code. So I converted this to Azure Functions last night because I realized I don't have to do AWS anymore. And I like AWS, but I wanted to try Azure Functions. So it actually didn't take much change. I really only had to change things related to the context item. I just had to change the name of them. So this is my serverless function. I can require an NPM module. Yes, thank you, code. Calm down. You can require in NPM modules, just like I normally would. Azure's running at least Node 8. AWS Lambda is running Node 8. A lot of them are at least running Node 8, and they're working on Node 10. I know that's not the newest and shiniest, but again, if you don't need the newest and shiniest, it's the asterisk. It's part of the trade-off. So you export a function. In this case, it's called hello because I forgot to change it from the boilerplate name. But what it does is it takes the context in and it asks for the query parameter of color. And if it's not there, you get an error back saying requires URL parameter color. The website doesn't show that because it was 2 a.m. when I finished converting this, and I was like, I'll do the website later. But the Azure function itself still works. Context.done. Else, let send color. It tries to convert it into an actual color. it throws an error from the color library, so I used a try-catch block here, and if it catches an error, sends an invalid color status back. And otherwise, it connects to a Mosquito service run by Adafruit called adafruit.io, in case you thought I would be silly enough to put my password up here. Heh heh. Oh my goodness, I've been walking through code that's not on the screen. I switched. Oh, I see why. Okay, hang on. Here we are. Why isn't it? Oh, because it's two different. It thinks it's two different monitors. I see why. All right, I can fix this. Place. Sorry, I should have looked down at the screens. All right, arrangement, mirror. There we are. Knew I'd forgotten something, and that would be it. Okay. Now you can see it, right? All right, so let's go back, walk a little bit through this. You can require an NPM module just like you would if you were running a regular Node server. And you create an export that's a function, takes in a context. It can take in a lot of other variables depending on your provider. Azure gives a bunch of other variables that I didn't particularly need. I only really needed the context because what I wanted from the context was the ability to manipulate the HTTP response, which is what I do if there's no parameter, query parameter for color. I should probably make that a little bigger now I'm looking at the slides. Okay. There we are. Yeah, that's better. So if you don't provide a query parameter color, gives you 400. Otherwise, takes the query parameter for color, tries to run it through the color library. If it throws an error, gives you back an invalid color status. Otherwise, connects to a Mosquito service, Adafruit.io, which I'll show you in a moment. What Mosquito is, it's commonly used in IoT. It's a communications protocol that's pub/sub based. So if you're a JavaScript developer writing robots, it's pretty great to have a pub/sub-like interface to attach to. And when you get a color, I publish to this feed the color, red, green, and blue channels. And then the Raspberry Pi here is watching the same feed, and so when something's published to it, it gets an event with red, green, blue, and publishes it to the screen there. And then if that works, it succeeds. It sends you back a 200. Otherwise, an error, Adafruit.io error, if it can't connect to Adafruit.io. That was really handy last night because I forgot to fill this in. Spent an hour going, why isn't this working? And I forgot I changed this to haha, nice try, and then deployed it. And was wondering why I wasn't connecting to Adafruit.io without the proper password. You know, always put errors in your code, folks. And then otherwise, if it doesn't have a sent color, that means it somehow got through the color library without it being assigned an actual red, green, and blue channel, so it sends back an invalid color. So that's the function itself. I'll show you a little bit more about like the system it runs in. So I've got my Azure dashboard here, and if I go to function apps, I've rehearsed this one. I can, node.conf view18, let me make this bigger. Okay, and then you can see functions. Hopefully it won't say inaccessible this time. I noticed a few times last night it was like inaccessible, and I'm like, wait, what? And I would refresh and it'd be fine. Oh, there we go, hello. So you can actually see in Azure dashboard, once it loads, you can see it's the exact same code with my actual passwords. I'm gonna scroll past that real quick. You can actually see it's the same code, deploys up there. You can actually even edit it in the dashboard. It won't push it back down to your local machine, of course, but you can play around with it. There are also really good dev tools in here and some pretty decent monitoring tools, and we'll talk a little bit more about that back in the slides. And then this is the Adafruit.io feed. Wow, y'all are really having fun with that badge. Because you can see, well, you can't, whoa, that's not responsive. Oh, it's responsive. Good job, Adafruit. All right, so you can see it says in a few seconds. I think that's because of the time zones. I've never seen in a few seconds before. But you can see the colors that y'all are sending go through the Mosquito. So, all right. Now that we've gone through the demo and walked through our serverless function. Oh, one last thing. If I want to take that code that I've written and deploy it, I'm going to make this a lot bigger so y'all can see. And I'm going to do the very, very difficult process of deploying this to Azure. That's it. Serverless deploy. I use the serverless framework. There are lots of different frameworks out there. It failed this time, because of course it did. It doesn't usually fail, but Of course it doesn't. Anyways, I swear it works. Please, I know you're laughing out there giggling that it's not working. I swear it normally works. But don't we all say that? Anyway, at least I have proof it works. So I also kind of want to talk about what serverless is not, because we have this tendency as web developers to go, ooh, new technology. It's a hammer. It's going to solve every problem I have because everything's a nail. No, everything is not a nail. Serverless is not a hammer. It's not going to fix every single one of your problems. Serverless will solve some problems and will make other problems worse. And I know you're thinking, really helpful, Cass. Thanks. You've just solved everything for me. Great. Good job. I'll go a little bit more into what it does solve. Serverless solves the problem of, I need to run this code, but it only traffic spikes at intervals of a time period greater than 30 minutes, and it only takes less than 5 minutes, and I don't mind a few seconds in latency every now and then. I go, whoa, whoa, wait, whoa, 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 whoa. A few seconds of latency every now and then? Whoa, shut it down, deal breaker, I'm out. I'm out. If you can't stand a couple of seconds of latency every now and again, serverless is not the hammer for you. Because we have this thing in serverless called cold starts. And what they are is when your serverless provider needs to spin up your runtime environment so it can run the function before running the function, leading to additional latency for that first invocation. That is a cold start. And depending on your provider or your language, cold starts can be quite a long time. Node tends to be around 1 to 2 seconds on most providers unless you have a ton of dependencies. Java can take up to 50 seconds if you have a giant jar file and tons of dependencies. So it really depends. You want to build out a proof of concept for your application for serverless before you figure out, OK, do I want to do this? How long are these cold starts going to hit me for? But that's true with any new technology. You always want to try it out and see, is this going to work for my application? Because cold starts are timey-wimey, wibbly-wobbly stuff. I know I said that wrong, whatever. So why do cold starts exist, though, if that's such a problem? If it's seconds of latency every now and again, why do we allow it? But that's what you're paying for. You're paying for the time your function is running. So obviously, if they're not keeping a runtime warm for you all the time, they've got to spin up the runtime when you need to run your function. And then when it hasn't run for a while, they'll spin it back down. That's the trade-off, just like every technology. So how do I avoid cold starts? If your main question for your serverless application is how do I avoid cold starts, you probably need to not be using serverless for your application. Not at me unless you have genuine questions about serverless architecture. Summary of when serverless should work for you. If your code needs to run periodically, and you don't need a server 24/7 to host your code. If your functions don't take minutes to run or don't need a long-running persistent connection, you do not run WebSockets on serverless. I've gotten that question before. How do I run a WebSocket on serverless? And I've gotten really mad responses when I respond, you don't. Because you don't. Anyway, if your traffic tends to be more sporadic than constant, serverless might be for you. If your traffic is more constant, then you probably need a server running all the time to run that code. You see what I'm saying? It's for certain situations. There's a really good website I have stickers for called servers.lol. I'm going to show it to you. And what it is, I'm also going to show you more cats, because why not? I have stickers. They're like holographic in my bag. So if you like this site and you're interested in a sticker, let me know. So there's a calculator here. It's for EC2 and Lambda, but it's very easily translatable to whatever cloud computing and serverless provider you'd like to use. It asks you what language you want to use. So we're going to pick Node because we're at NodeConf. Can your app finish within 15 minutes? We'll say yes, because we just talked about how it should finish in a short amount of time. We don't have to fill all this out. We're going to say we use very little memory, right? And we're going to say active high spikes for traffic. And then what instance type are you running? We'll say like a micro, 1 gig memory, 1. All right, and then get results. yay, your application is a great candidate for serverless. And it'll actually be honest with you. If you pick like constant traffic, or you say Haskell, or you answer something that's not quite there yet, it'll say you might not be a good candidate for serverless yet. Because while a lot of languages are supported by serverless, some are supported by uploading a precompiled binary. And I'll talk a little bit more why that's really tricky and why that's not necessarily something you always want to do. All right, so servers.lol. So what's the catch, right? Besides cold starts, what's the real catch? The trade-off, the main trade-off I've noticed is observability and metrics are usually a nightmare in serverless because you don't have control over your runtime environment. Because you don't have control over it, it's really hard to poke and prod and see how much memory am I using, how much CPU am I using, how much is this, that, the other. If you don't, and in fact, especially if you don't know for sure what runtime you're going to be on or what the container looks like or et cetera, it's really hard to get this information. And developer tooling from most providers is kind of a nightmare. Almost never speak in definites, but this is also just true. Props to Azure Functions, their dev tooling is really great. You can run your functions locally. They have a step-by-step debugger. Their dev tools are just like pretty great. And they have a pretty decent built-in metrics platform. It's getting there. It can take up to 5 minutes for the metrics to propagate, which if you're trying to debug a production error, but if you're trying to debug a dev error, all right, that's a little better. So I kind of went into this, but why are observability and metrics so difficult? So remember the jawbreaker that was the abstractions? So like it's kind of like trying to see into the center of the jawbreaker without sawing the jawbreaker in half, because you can't saw the jawbreaker in half because it's not your jawbreaker. You know what I'm saying? It's harder to get at the information, the metrics and observability for what you're looking for in your application if you abstract it out. This is especially true if you upload a compiled binary for your language to AWS's bring your own runtime. It's almost impossible to see into those things because it's a jawbreaker running inside a jawbreaker. It's really difficult. Your serverless provider, in most cases, determines what you can and cannot see about your application, how it runs. There are some third-party tools that are coming up. IOPipe, Serverless framework just announced they're doing a metrics platform. There's a lot of third-party tools for developers and for metrics and observability that are making headway into the space, and they're turning out to be really great. And again, some providers are stepping up to the plate. Azure Functions has really made a really good dev experience for serverless. They've still got a ways to go before it's like perfect, great, everything's solved. But as for way providers go, from the providers I've tried, which is many of them, they've got one of the best experiences I've found. Did I miss serverless? Does the fact that this person is up on stage shouting about it means it's over already? Am I too late? No. Did I miss it? No, you didn't miss it. We have conferences now that are all about serverless, but they're still relatively small, and it's growing every day. The serverless community and the use of serverless is growing every day. The place I would point you to if you're like, okay, this is cool, but where do I go next? I would start at serverless.com. That points you to the serverless framework. It works with all of the major providers, and it's kind of a really great CLI tool to kind of help you gather all the information you need to get started and go. And they've got pretty decent documentation on their tutorials, things like that. So I'd go to serverless.com and try the serverless framework if you're interested in learning even more about serverless and trying it out. Thank you very much. I know he's tiny up there, but Carl Sagan and I both think you're awesome. Again, I'm Kassandra Perch. I'm a dev advocate, and if you need dev advocate services, I have cards in my wallet. If you want a sticker, I have server.lol stickers, or serverless.lol stickers in my bag. And if you're interested in the slides or the demo code, they're up on GitHub at that URL, or you can also ask me later today. Thank you so much, and have a great rest of your day.